The output sequence is convolution of the input sequence. This is a sign we use for convolution. Xn convolved with h of n. And when you have to actually compute, I'm using nt, then h of m minus n, and where m is a dummy variable. So related to this, we have correlation. It's a similar kind of an operation, and it is defined as, say, R summation n runs from minus infinity to plus infinity x of n, and if the other sequence is h of n, then it will be n minus n. And I'm sure आप सबको पता होगा relation correlation. It can be either auto correlation or it may be a cross correlation. Auto correlation, we don't have a second sequence, we only have a one sequence x of n. Cross correlation, we have two sequences. The theoretical aspects are different, although they are similar. There's only a difference of sign, but convolution, it gives you much more understanding of a system. आपका जो correlation है, it only tells you that if you have two sequences, how much they correlate, उनमें similarity कितनी है. Yeah, if you have a one sequence, how much it correlates with its delayed version, right? Convolution, on the other hand, it gives information about the system. I'm sure आपने signal processing का जो आपका basic course होगा, you know that one of the characterization of your system is in terms of the impulse response. And it is basically this. H of n is the impulse response. This is your input, and you can determine the output. Theoretically, it means if you have a system and you know what the response of this system is to the impulse function, then you can find the response of this system to any other input, which we normally denote the x of n. तो हर किसी की अपनी physical significance है. Convolution is much stronger a function as compared to correlation, although mathematically they seem to be similar. Anyways, we're not here to discuss the theoretical aspects. We are here to write a code which will compute the convolution of two sequences and correlation of two sequences. Now, when it comes to the computation, जिसके लिए हम code लिखेंगे, there is a tabular method that we often use while calculating convolution or correlation using pen and paper. एक थोड़ा matrix related method है. Now, since you are Scilab as well as your MATLAB, it is basically designed for matrix data type, a matrix input. So we will be using that method to write a code that will compute convolution or correlation of two sequences. So I'll take a quick example here. Suppose I have two sequences. X of n is a small sequence and it has elements 1, 2, and 3. Then I have another sequence, let's call it h of n, having the elements -1, 2, and 2. As far as computation is concerned, if you have to find the convolution of these two sequences, we construct a matrix, we construct a table. जिसके एक side से you enlist your x of n. So this will have the first element x1, x of 2, x of 3, which is 1, 2, then 3. Fine. Similarly, जो आपका दूसरा axis होगा, that will have the other sequence. So this will be x2. Okay. So we kind of construct a two-dimensional matrix. Then we perform the products. So -1 into 1, that will be -1. -1 into 2, -2. -1 into 3, -3. Similarly, 2 into 1 is 2, 2, 2 is 4, 2, 3 is 6. Then 2, 1 is 2, 2, 2 is 4, 2, 3 is 6. फिर जो आपका convolution compute होगा, it will be along these diagonal elements. We form these pairs या these जितने भी elements इसमें आएंगे. तो जो ये वाला पोर्शन है, this will be your y of 1. So y of 1 is -1. ये जो ये दो elements है, you add them up, that will form your y of 2. So y of 2 will be 2 plus -2, that is 0. Similarly, to find y of 3, ये जो ये वाला portion है, इसमें जो भी entries आ रही है वो form the sum. So it will be 2 plus 4 is 6. 6 minus 3 is 3. Likewise, y4, it will be 6 plus 4, that is 10. और आपका जो last element होगा, y of 5, it will be simply 6. ठीक है? So आपके x of n में there were 3 elements. आपके h of n में there again were 3 elements. और आपका जो convolved sequence आ रहा है y of n, which is this -1, 0, 3, 10, and 6. It has 5 elements. And there is basically a deterministic relationship between the number of elements in your inputs और आपके output कितने element होंगे. Generally speaking, अगर आपका दो sequence है x of n, say it has m elements, then you have another sequence h of n and it has n elements. इन दोनों को लेके you will form and you will convolve these two sequences. You will have y of n जिसमें you will have m plus n minus 1 elements. ठीक है? Since जो हम code लिखेंगे, it will be a generalized code wherein we'll be prompting the user to enter the sequences. So this information is must, this deterministic relationship between the, you can say, length of the input sequences and what is going to be the length of your convolved sequence. Another interesting thing is that if you express this as a sum, so y of 1, it basically is this product, x of 1 into h of 1. आपका जो y of 2 है, it is this x of 2 multiplied by h of 1 plus this element. This, so x of 2, h of 1. Okay, that is this element, x of 2 into h of 1. And then we will have this element, which is x of 1, h of 2. Similarly, आपका जो y of 3 होगा, it will be x of 3, h of 1 plus x of 2, h of 2 plus x of 1, h of 3. And likewise. Now, an interesting thing here is, again, from a coding aspect, जिस बात का हमको ध्यान रखना है, when you will actually form these product terms, you see, let's consider this one for instance. इसमें x का जो index है 3, 2, 1 in these three product terms, and h का जो index है 1, 2, 3. So while as the index of your x, one of your sequence, it is decreasing in these product terms, आपके जो दूसरे sequence का index है, it is increasing. Had it been x1 into h1 plus x2, h2 plus x3, that was pretty straightforward. But यहाँ पे हमें we'll be actually creating a loop for this, क्योंकि आपका multiplication repeat हो रहा है multiple times. But here there's a slight problem here. One of your operands have indexes that are decreasing from 3 to 1, which is x in this case. और जो आपका दूसरा operand है h, इसका index increase हो रहा है. So you can't directly have a loop and then say that y of I is simply x of I into h of I. You have to work on these indexes because for one of your variables, the index is decreasing, and for the other variable, the index is increasing. Anyways, this is how we compute convolution using a tabular method. We have a similar kind of computation, just for the record. ये convolve करके हमारे पास जो sequence आ गया, so this is actually convolution, and the sequence we got was -1, 0, 3, 10, and 6. Now let's do the other operation, that of correlation, using the same example. अब चूंकि हमारे पास यहाँ पे दो different sequences है, xn is a different sequence and hn is a different sequence. So what I will be actually specifically calculating will be cross correlation because I have two different sequences. Had it been only one sequence, it would have been autocorrelation. इसका भी when you have to compute it, there are multiple methods, and we will use a method similar to this kind of a table. So again, we will have on this side, I will have my x. So this will be x of 1, x of 2, and x of 3. और यहाँ से I will have my another sequence h of 1, h of 2, h of 3. और जो specific values हमारे पास है 1, 2, and 3. Then I think I have -1, 2, and 2. इसमें भी you will do the similar kind of computation. So -1 into 1 is -1. And -1 into 2 is -2, -3. यहाँ से 2, 4, and 6. And 2, 4, and 6. So, but the way you will organize these elements to compute your correlation is slightly different. There's a difference in the sign, and that difference basically इसमें you will follow the other pattern. यहाँ पे आपने ऐसे किया, यहाँ पे it will be like this. Right? वो जो आपका correlated sequence होगा, yeah, let us do element wise. So RXH जो आपका पहला element होगा, it will be simply this 2. तो जो आपका दूसरा element होगा, it will be 2 plus 4, that is 6. Likewise, I'll do one thing, I won't use the index. यहाँ पे भी I start from y1, y2, y3. So to maintain uniformity, let's start the indexes from 1 itself. 2 and 3 will be 6 plus 4 is 10, 10 minus 1 is 9. इसी तरह आपका जो fourth sequence है, that will be 6 minus 2, 4. And your fifth element will be -3, which means जो आपका correlated or cross correlation in those sequence के बीच में होगी, it will be this sequence 2, 6, 9, 4, and -3. This is the computation. इसमें भी number of elements are exactly the same, like in convolution. So this is the how we compute these quantities. Physical significance is different. You know, correlation, it basically gives you the degree of similarity, or sometimes we say degree of overlap between two sequences. Whereas convolution is a more complicated function, which helps you to characterization of the system, especially a discrete system. There are basically three equivalent characterizations of your system. One is impulse response, which is basically this convolution sum. Then you have the difference equation. और फिर frequency domain में आपका system function आ गया. Right? But when time domain is concerned, convolution is regarded as one of the property which you can actually use to design, first characterize, analyze, then design a system. And this is the way we compute it. I hope you have to follow किया होगा. Now we will try to write the codes for convolution of two sequences, correlation of two sequences, and some other alternate methods based on this understanding. Okay, so Okay, I don't need to do anything. So I will just try to map this to. Okay, I will be just exiting from my tab here. Now I will communicate through the laptop app. मुझे वहाँ पे मतलब software is installed in the laptop itself. Okay, just a give me a few seconds so that I can switch.
Okay, am I audible?
Yes, sir.
Yes, sir.
Okay,
So if you're on your laptop, you can open your editor. We'll just try to write the codes for these. Okay, I've shared my screen here. Here's my Scilab. Okay, so we had a working directory on the desktop, या जहाँ पे भी आपने store किया होगा DSP programs. So we had done these programs अभी तक जो भी हमने किए. So तीन हमने पहले ही किए थे. We did time shifting here, scaling, and we also did the time inversion using unit step. You could have performed the same thing using जो भी हमारे elementary signals थे, be it ramp, yeah, impulse, whatever it was. So okay, I think we had a problem in one of the codes. I don't remember which one. आप ऐसे ही किसी ने point किया था उस time. Let me see, scale. Inverting. So time shifted, if we try to run this, number of samples, so let it be 9. Amount of shifted 2. So, okay, I thought दूसरा एक कोड था जिसमें दोनों waveforms आ रहे थे. Let me just give me a second. So I think it was this inversion क्योंकि हमने इसमें दोनों किए थे. Okay, if I run, number of samples say 9, then okay, this was the problem I think. आप में से किसी ने point out किया था कि we are
Yes, sir.
did anyone rectify किसी ने घर पे देखा कि मतलब
Yes, sir.
problem? Okay, so what was the problem? कोड में कुछ issue था?
सर कोड में था कि आई एंड जे को फिर से इनिशियलाइज करना था. आई इज इक्वल टू 1, जे इज इक्वल टू 1. जब हम इन्वर्टेड स्टेप लेते हैं तब.
Just a second. So we have initialized I and J here.
Yes, sir.
So this runs for अच्छा आप कह रहे हो कि यहाँ.
Yes, sir.
So okay. So once we are out, we go into the second loop. So we have to again initialize it. Control C. So यहाँ पे
Yes, sir.
Control V. Let's see if it works fine. Say 9. Okay, ठीक है. So it has been rectified. Anyways, thanks. So ये छोटी मोटी चीजें हो जाती है. So you need to rectify these things. Anyways, okay, this is rectified. So as pointed out by the guy, आपको यहाँ पे हाँ, you have to initialize it twice. Every time you run a loop, your I and J should start from the initial value of 1. Okay, let's see. Anyway, so ये हमारे basic discrete operations थे. So we will start with the first code that will be coming the convolution of two sequences. So as usual, we'll start with clearing the screen. then clearing our local variables. Now, if you remember, जो अभी मैंने बताया, we have to prompt the user for two sequences. Let's call the first sequence as X. So it will be input and sequence. Then we need another sequence, which basically is the impulse response. Differentiate करने के लिए enter impulse response. And first of all, I need to calculate what is the length of these two sequences, because that will define what will be the length of my output sequence. So uske liye we have a script, we have the keyword. So let us initialize a variable n that will actually have the value for the number of elements that my first sequence has. Similarly, I will define another variable m that will have the number of elements मेरे दूसरी sequence में है, which is actually the impulse response h. तो हो गया ये. Now next, I will have to initialize a loop that will compute these product terms and then sum them up. So, but again, the issue is कि जैसे मैंने इससे पहले I tried to explain it using that particular example. कि one of your this sequence x, it has decreasing index values x3, दूसरी term x2, तीसरी term x1. जो आपका दूसरा sequence है, the impulse response, it has increasing value of the index terms. So पहली product term में it starts with h1, then h2, then h3, and so on, depending upon the length of the sequence. Now, since I am generalizing here, so I will start a loop for say k. We will use this as an identifier, and again, we started with x1, x2, x3, similarly h1, h2, h3. So I will start k from 1 right up to, because I'm going to have m plus n minus 1 elements. And I need to update it. So if I initially assume, initialize my y of k, y is basically my convolved sequence. So I'm kind of initializing it to 0. Then product terms. Okay, I will have to use another loop for, just give me a second, j, if I was this, so this is another identifier. There are various ways of defining this. The main issue is how you define these index terms. So we will define it using max and min terms. Maximum, because I have to then k is equal to 1. Just a second. So I think it will be between, since we are starting with 1, then k plus 1 plus m. So this index I'll be using for x, or minimum. One of my indexes is k, and I'm using for x. Then I think n. So I think it should be like this. We'll check it once we are done with the code, and we'll run it first just to see whether it works fine or not. Okay, this is for defining these identifiers. जिनके basis पे I'll be calculating my output sequences element wise. So y of k will be updated as y of k, and I have to define the product. Product में पहला मेरा x आएगा जिसका index j है, then product multiplied with H ka index should be the lowest one. So I think K plus 1 minus J. Like this. So this ends my internal loop. And I will end my. We'll try to first display the quantity. Check whether it's fine or not. Okay, let me go run for CLC fine input. यहाँ पे तो ठीक है. For K is 1. Okay, this is the index for Y of K. Then I'm initializing this is fine. Or J is equal to max of this. So initially it will be 1 K plus 1 and min this and this. And then yeah. Okay, let's try to run it. So this is our convolution. Let's see. Enter the first sequence. So if I first sequence is 1, 2, 3, and my impulse response was, I think we had used -1, 2, and 2. Okay, it's showing only one element, -1. Just a second. Oh, okay, sorry. We have to enter it as a sequence. Sorry. So I think I have to use a proper way using this 1, 2, 3. And for impulse response, it was -1, 2, 2. Here are the values: -1, 0, 3, 10, 6. So I thought we had similar values when we computed manually. I'll just have a look at my tab just to check. So yeah, -1, 0, 3, 10, and 6. Fine. So what is better? We actually plot these values. So we will use subplot. इसमें so I have to impact, okay, 3, 1, 1. Then जो आपका normal है plot. Yeah, let's do one thing. Plot हमने both use किया. There is one more regarding these 2D graphics known by bar. I'm sure आपने पढ़ा होगा. So उसमें it will give a better visualization of this kind of an operation. So X, that is my first input. Then you pass on some parameters. What should be their pointer value? Yeah, what should be the color? For example, X will plot in red. Similarly, you can then put a title. वो चीजें आप खुद कीजिए, हाँ? Title and all that. I will just try to formally plot it here. This one will be for our second sequence H. Let's use the color blue. And 3, 1, 3. Let's use 13. I'm not using any titles or that, so you can do that. Run. Let's see. So one of the sequences 1, 2, 3, and the other one is -1, 2, 2. Fine. So this is your X of n 1, 2, and 3. Fine. This is defined at 3 points 1, 2, and 3 here. Okay, amplitude 1, 2, and 3 here. फिर आपका ये है. This may be confusing, but you can always edit your axes. So, for example, in this case, I can edit it. Axis 2 ka. Can bring it to middle. Fine. Like this.
Sorry, sir, you write last one plot of X.
In the code.
green one.
हाँ, okay, I have to write y. Okay, I'm sorry for this. We'll have to run it again. So 1, 2, and 3. हमारा impulse response -1, 2, and 2. ये ऊपर इससे दिखा रहा है कि because it my y-axis is starting from -1. That's the reason ये ऐसे दिखा रहा है. But you can always adjust the axes so that it is better visually perceptive in a better way. And this is your convolve sequence. -1, 0, 3, 10, and 6. So this is how we do convolution. इसमें जैसे मैंने कहा, when we discuss the computation using pen and paper, you have to take care of these indexes because one of your indexes is decreasing in your product terms, that is, और दूसरा आपका index it is increasing. Fine. तो x का इंडेक्स आपका डिक्रीज हो रहा था 3 to 1 और h का इंडेक्स इंक्रीज हो रहा था. So you have to use bit adjustment. I normally use these two commands, max and min, when you have to actually generalize. अगर आपका सीक्वेंस यहीं पे डिफाइन होगा तो उस टाइम पे बहुत ही सिंपल होगा क्योंकि हम यहाँ पे जनरलाइज कर रहे हैं and we are prompting for the sequences which can be of different lengths. For example, if I run it, I can define any sequence, say 1, 2, 1 of any length. Like this. इसी तरह आपका impulse response भी length, but it will give you the output. So we're not reserved to a particular length of sequences. We can generalize. उसके लिए it is better to define your indexes in the for loop using max and min. Yeah, in another general way, जैसे आपके पास which is convenient to you. But the funda is here. The main why I'm doing this stuff here in the for loop is because I have one index dropping from a higher value to lower value as we compute the products, और दूसरा index is moving from a lower value to higher value in the subsequent products. ठीक है? And plotting के लिए you can use plot. I have used bar, थोड़ा इससे better visualize होगा. Now this is kind of a direct method जहाँ पे जैसे आप theoretically calculate करते हैं अपना convolution sum, and I try to replicate the same thing here, but we also have a inbuilt keyword. Although if you are writing a code for convolution, it's always advised कि आप scratch से अपना code लिखिए, don't use the inbuilt keywords. But sometimes your convolution operation is a part of some bigger operation. For example, if you are designing an FIR structure or IIR structure, तो उसमें you can directly use the keyword. And the one thing, I will write another code जहाँ पे we will be trying to convolve two sequences using that keyword. Okay, so let me just copy this entire thing here in the numerator. So this will be convolution of two sequences using the inbuilt function. Yeah, keyword, whatever you want to call it. So as a case made it simple, you have CLC, clear and all that. X आ गया, H आ गया, you don't need these parameters. You want to delete it. आपको loop भी नहीं चलाना है, just erase everything. All you have to do is just call that function. So आपका जो y होगा, it will be directly convolve. This is the keyword. Then you pass on the parameters. पहला sequence, दूसरा sequence, and it will directly give you the convolution of these two sequences. Okay, so let us just save and run. So this will be again convolution, but using second method जहाँ पे हम directly function inbuilt function को call कर रहे हैं. And again, just to check, I'll use the same sequences 1, 2, 3. Impulse response के लिए let's use -1, 2. So you have some results. ठीक है? So if your convolution operation is a part of some bigger operation, bigger calculation, those time you can directly use their function convol into the convol of the two sequences. Then we have a third method. Again, it depends upon applications. कभी-कभी आप time domain में, I mean, जो आपका calculation होता है, it may get seriously involved. So उस time पे we switch to frequency domain. And you know कि अगर आप convolution operation, we have two sequences, x of n, h of n. And if you transform this into frequency or frequency related domain using Fourier or using Z transform, तो आपका जो convolution operation है in time domain, it transforms to simple multiplication operation in the frequency domain. Right? So if x of f is the Fourier transform of x of n, and h of f is the Fourier transform of h of n, the job of convolution operation, it is simply the product of x of f and h of f. Okay, so this is yet another method. So let's try that one. If you are doing it in the frequency domain. So kuch cheezein common rahengi, so I will just copy the first part as it is from my original code. This up to this point. C will be, this is convolution of two sequences using fast food. क्योंकि Fourier transform हम Scilab में we computed using fast Fourier transform. So I have two sequences, x and input, and the other is h. One you can call the normal input sequence and दूसरा आपका impulse होगा. But यहाँ पे जैसे मैंने last time भी कहा था, when we did the frequency spectrum analysis of signals, when you take FFTs, you have to define it over some sample points. Now, if I directly take FFT on x, then directly take FFT on h, it is possible कि in those sequences की length different होगी. For example, x may have 5 elements, h may have 4 elements. फिर जब इनका Fourier transform निकालेंगे वो तो निकलेगा, but once you try to compute the convolution then. So actually what I'm trying to say is if I directly compute f of 1, f of t of x, then compute f of 2, f of h. If I directly define f of 3 as an element-wise product of dot f2, this may not work. Because FFT is always computed on certain number of points. So last time we said FFT is not a transform itself, it is just an algorithm that is used to compute your discrete Fourier transform. And DFT is always defined about a certain number of sample points. So if I go for direct this kind of computation, convert if I find the Fourier transform of f of x using FFT, find the Fourier transform of h using FFT, then simply multiply. Then if I take the inverse function, क्योंकि जो मेरा time domain में convolved होगा, it will be the inverse Fourier transform of the product, that is f of 3. So इसमें आपका जो issue आएगा, it won't be sample by sample. आपके samples they will be shifted, right? Because of the difference in the length of the original sequences x and h. So we have to ensure कि आपका x और h they should have the same length. अगर आपके x में 6 elements है, आपके h में भी 6 elements होने चाहिए. So that when we actually perform the transformation and we actually use the FFT operation, it will be defined for 6 points in both the cases. Then we will take the element-wise product. Again, it will be defined FFT. Then when we take the inverse Fourier transform, वो आपका बराबर आएगा in that order, yes, जिसमें आपको चाहिए. Now, one way is you always restrict your sequences. X की भी length उतनी होनी चाहिए जितनी आपकी H की है. Second method is we go for zero padding. मान लीजिए X का कुछ length है, H का कुछ different length है, तो उनका length same करने के लिए we add zeros in both the sequences. In order to have a generalized procedure, what I will do is here is a small modification. I will define a variable capital N as sum of N and M, जो आपकी दो length से subtracted by 1, because this is actually the length of the sequence जो आपका output होगा, जो आपका convolved sequence होगा. Then I will go for zero padding. So I will redefine my X. So X will be updated as original X, then zero padding. Zeros, that will be, you will have to add zeros. To this. And हम X के, हाँ, and हम X use करें. Similarly, you will have to redefine your Y. Original Y, then zero padding. 1 up to 10. मतलब इतने zeros में add कर रहा हूँ. So when I do this, I ensure that regardless of what the sequence value, the length sequence is there when you prompt the user, but this thing will ensure that once this calculation is done, आपके जो दो sequence होंगे, they will have the same length, right? So that when we compute the Fourier transform, it won't affect the result. तो बाकी फिर यही रहेगा, F1 को directly you can compute the Fourier transform of X. Keep it in F1, similarly F2 में ये, then compute their product, element-wise product, then perform the inverse function. This will give you the convolution. So plotting के लिए I will just copy paste this portion. Like this. So let's save and run. So this will be over again, convolution, using the third approach. So let's use the same sequence, 1, 2, 3. And then we had -1, 2, undefined variable Y. Let's just check. Y is equal to IF50, F3. This. Oh, sorry. We have, okay, हमारा जो दूसरा H.
H होगा.
हाँ, यहाँ पे and X, this is fine. This one, okay, again, let's rerun it. So there's 1, 2, 3. Okay, so we have the similar kind of result, but we have used it there for this, the transform. Sometimes you see, you may say, why do we need alternate methods? Although it doesn't make sense. You are working in the software, so it doesn't make much sense. But when you actually implement these systems, especially in hardware, so sometimes convolution का जो computational overhead है, because you have to perform product and perform the summation. So you need a lot of adders, you need a lot of multipliers. जो computational overhead है, but sometimes it's not justified. मान लीजिए you are performing batch processing, जिसमें एक batch में there are hundreds and thousands of samples, and every sample is coded as 8 bits as 16 bits. So it becomes a lot of computational overhead to perform bit by bit product, then to add them. So a lot of resources are wasted. So it's better you go for transform कीजिए, और transform के बाद you just come for here, calculate the product, then perform the inverse transform, and you get the same sequence. But यहाँ पे एक बात का ध्यान आपको रखना है कि when you transform from time domain to frequency domain, आपका जो shift होता है, आपकी जो axis होती है, या जो आपके sample values होते हैं, they get shifted. Right? तो इसीलिए मैंने यहाँ पे I use zero padding. We use this a lot in transform theory. And we transform from time to frequency domain in an implementable system, not in a calculation के हिसाब से तो कोई ज़रूरत नहीं. But when I have to actually design and implement a system, we make sure कि हमारे जो time and frequency axes हैं, they are kind of matched. There's a one-to-one correspondence between the two. उसके लिए we often go for zero padding. Right? So this can be yet another method to implement your convolution. So we have the direct method, जैसे हम theoretically tabular या matrix method से calculate करते हैं. That is your this code जहाँ पे आपको ध्यान रखना है about the indexes, because one is increasing, another is decreasing. If your convolution is a part of some bigger operation, you can always use the function convols. You'll pass the parameters. It will directly give you the convolution of two sequences. And if you're interested in the frequency domain, yeah, you're going for hardware implementation. You don't want that much of computational overhead. या आपकी sequences बहुत लंबी है, तो उस case के लिए it is better to go to the frequency domain, perform convolution as multiplication in the frequency domain, then perform the product, get the inverse transform. That will also give you the convolution of the two sequences. ठीक है. इसी तरह आपका correlation है, तो correlation will be pretty similar. So I will just copy paste this code, because you know, अगर जो summation की equation, which is the basic equation of correlation, there is a difference in the sign. So वही difference you have to do. So it will be something like this. Let me just modify this one. You will again have two sequences. अगर दोनों sequences same है, so it will be autocorrelation. So let's for the time being assume we have different sequences, so that we are computing the cross correlation. That is the amount of similarity between the two sequences X and H. Fine. So यहाँ पे we don't need to put impulse response. You can simply say enter the second function, second sequence. So you have two sequences X and H. You do need their lengths, and यहाँ पे you will have to modify, क्योंकि आपके जो index values होंगे, they will be so J. यहाँ तक तो बहरहाल same ही होगा, but यहाँ पे it will be different. X of J, H of, where is M? M is length of H, so K is defined over. Just a second, I will have to. K is defined over 1 to M plus M minus 1, where M is the length of H and is X. So number of elements again दोनों केस में same ही रहता है, so this will be similar like in convolution. Then you have to initialize. This is fine. Now defining the J index Mx, this is again fine, but I will have to modify, I think here, X of J. Now since this is negative, so it will be minus वो plus हो जाएगा, so this will become, oh, sorry, plus, and it will become minus. There you don't need to put M, you can simply put M. Sorry. It will be minus K plus M plus J. Then you can rearrange so that it is better perceived. So let me put M first. And like this. I think it should be like this. We'll just try this cross check giving the inputs. बाकी यहाँ पर display भी वही है, subplot and all that, it remains same. So let's save and run. So this will be my correlation. Fine. Let's go to the console. So we'll use the same sequence क्योंकि उसके theoretical values हमें पता है 1, 2, 3. Then the second sequence we have -1. So I hope the values are same. I'll just check on the tab. We had 2, 6, 9, 4 and -3. Okay, so इसमें आपको again it is the matter of a sign. Yeah, if you have that sum, look at the summation equation. एक में I think it was m minus n and दूसरे में it was n minus 1. So it's all about the sign itself. So correlation में we had n minus m in the second function. The convolution में m minus n. So वही sign, it will affect your indexing, and you can adjust the index right here like I did in this code. And this will be your correlation. It may be auto correlation अगर आपके दोनों sequences same है, or it may be cross correlation if we have two different sequences. Okay, so this is how we compute correlation using this. I am not sure कि like convolution का हमारा एक पूरा inbuilt function था convol, I'm not sure about correlation. वैसे होना चाहिए because I don't work with Scilab. मैं ज़्यादा MATLAB पे use करता हूँ. So just try at your own place to find out if there is some keyword, if there is some inbuilt function. Just like for convolution, we have convol. Is there a similar kind of function in the correlation, in this for correlation? Okay. So these were some simple operations in है. Okay, can you share का huh? CORR. So you can also use that function. Huh? That will, yeah. Let's see if अगर यहीं पे काम करेगा. So instead of convol, you have to use CORWF. Okay. And that should give you the correlation between the two sequences. This is actually one of the advantages, and मैं ये भी कहूँगा one of the drawbacks of these high-level languages. So MATLAB है, Scilab है. It kind of handicaps your coding skills because everything has a function inbuilt. But I personally always prefer, especially जब आप सीख रहे हो, अगर आप project कर रहे हैं तो it's better to use functions. But जब आप सीख रहे हो, you should try to implement your functions yourself. जैसे we did it for convolution या we did it for correlation. Otherwise there are inbuilt functions. But जब आप सीख रहे हो कोई tool which is based on the high-level language, always try to build your codes from basic functions. So it gives you a better perspective, a better vision here. What is the strength of this language? Otherwise, आजकल जो भी language है, especially these which are simulator based या synthesis based, उसमें what you call, you have a lot of functions. You go for Python, you go for R, you have a lot of inbuilt functions, which kind of challenge your, kind of handicaps your coding skills. So that's all about this. These were some basic operations. आपके syllabus में था थोड़ा signal processing के बारे में. So we have done both analog as well as in discrete. We will have to do some more case studies regarding XCOS क्योंकि अभी तक तो हमने सिर्फ Scilab में किया. So I will just try to work out what will be the case study that will suit. क्योंकि we have people from ME as well as CIT. CIT वालों का background, it can be electronics, IT and computer. So I have to find out a common ground जिसमें आप सब चारों branches का कुछ theoretical हो. जैसे signal processing, everybody does it. Computer वाले भी पढ़ते हैं signal systems, electronics as well as IT. But फिलहाल के लिए from Tuesday we will be starting with और जो मैंने वो list upload किया था Google Classroom में. So उसमें जो मैंने topics दिए हैं, they are basically from this Scilab itself. So you don't need to look for other resources. आपको यहीं पे मिल जाएगा. Here you can find. तो मेनली इसी में से है, एक्सेप्ट फॉर सम एप्लीकेशंस लाइक ASK, PSK, FSK, उसके लिए मे बी आपको कुछ और रिसोर्स ढूंढने पड़ेंगे, बट मोस्ट ऑफ इट यू कैन फाइंड इन द Scilab हेल्प. ठीक है. सो जस्ट प्रिपेयर अ रिपोर्ट जो भी टॉपिक्स आपको दिए हैं एंड देन प्रिपेयर अ डेमो. जैसे मैं पिछले 2-3 लेक्चर से ये डेमो दिखा रहा था कि रियल टाइम में वी राइट अ कोड एंड रियल टाइम में वी रन इट एंड इफ देयर आर एरर्स रियल टाइम में वी ट्राई टू rectify them with prior preparation. Obviously, I also prepare. It's not that कि मैं यहाँ पे आके code लिखना start कर देता हूँ. I also prepare at the back. Similarly, you can prepare, and it is better to prepare through examples ताकि the audience we do understand कि how actually we can use this particular function जो आपको assign किया गया है. Okay. So we'll start on Tuesday. I will let you know किस time पे हम start करेंगे. But all of you should join. And क्योंकि आपके वो जो आपके कोऑर्डिनेटर है गफार साहब, तो वो आज पूछ रहे थे कि जो आपकी स्कॉलरशिप है व्हाटएवर स्टाइपेंड यू गेट इट विल बी बेस्ड ऑन दिस कि आपकी अटेंडेंस क्या है ऑनलाइन क्लासेस में. फाइन. सो इट इज बेटर आप ज्वाइन कीजिए सेशंस, यू विल लर्न समथिंग. सो नेक्स्ट टाइम राउंड इंशाल्लाह फ्रॉम ट्यूसडे वी विल स्टार्ट विद योर प्रेजेंटेशंस जो आप लाइव डेमो देंगे. एंड मैंने उस पर अपडेट किया है कि जो आपकी रिपोर्ट्स होंगी आई पुट आउट एन ईमेल आईडी देयर, तो आपने रिपोर्ट्स आप उसी ईमेल आईडी पे सेंड करेंगे. फाइन. सो वंस वी आर डन विद दोस डेमोस देन वी विल हैव अ केस स्टडी ऑन XCOS. तो वी विल डू दैट आल्सो. ठीक है. आई एम एंडिंग दिस सेशन.
ये जो हमारा असाइनमेंट है,
हाँ, जो असाइन किया ना आपको टॉपिक
जी,
तो उसी पे आप रिपोर्ट बनाएंगे.
ठीक है.
जैसे यहाँ पे अब लकीली यहाँ पे खुला हुआ है. फॉर एग्जाम्पल if somebody is from CIT. Like the first presentation is by Yavar Ayub. So some data types are types in Scilab. So you will prepare a brief report, what are the different types we use in Scilab. Then you will prepare a real-time demo जिसमें आप वो types use करेंगे. So that we get an idea कि कहाँ कहाँ पे use हो सकता है. Similarly, what are the different variables in Scilab? Fine. So again, you will prepare a report, RFSR, and you will give a demo using some brief examples. इसी तरह bitwise operation क्या है, discrete mathematics कैसे आप implement करेंगे, ये सारा उस help में आपको मिल जाएगा, वहीं से मैंने बता रहा है. And similarly, we have 3D plots in Scilab, a brief report and then a live demo. हाँ हाँ अब सेमिनार में आपका सिर्फ पीपीटी रहता है, तो यहाँ पे इट्स नॉट नेसेसरी टू क्रिएट ए पीपीटी, जस्ट डू द थिंग्स इन रियल टाइम आफ्टर प्रायर प्रिपरेशन इन द Scilab editor itself. ठीक है.
Sir, would there be any time bound?
Try to limit it within 15-20 minutes. तब क्योंकि ये brief topics है. अब types, data types कितनी ही है Scilab में, you have that boolean and all that. तो
Sir, and PPT is not necessary.
नहीं, you don't need to prepare a PPT, but report is necessary. Yeah, report is mandatory.
Okay, sir. Okay, sir. Thank you.
चलिए, we'll start inshallah on Tuesday. I'm ending this session. Okay.
Thank you, sir.